balloons and rockets, astronomers have successfully launched telescopes into Earth orbit above the distorting effects of the atmosphere. To explore deep space, NASA has had great success with robotic probes like Voyager that have observed and sent back images of our solar system. NASA and its partner, the European Space Agency, are now on the verge of launching a huge optical observatory into orbit around the Earth. Hubble Space Telescope will see objects even near the edge of the known universe with 10 times finer detail than possible from the ground. At the heart of the observatory is an 8-foot mirror ground to near perfection. When pointed at an object, the mirror collects light and sends it to 6 instruments. Various satellites and ground stations relay the instrument's information to the Space Telescope Science Institute in Baltimore, Maryland. Viewing screens will allow scientists to make real-time observations. At the same time, a tremendous amount of data will be generated, according to Dr. Eric Jason.
We're talking about a huge amount of information. In fact, we colloquially refer to this as drinking from a fire hose.
In order to help astronomers plan observations, the Space Telescope Institute has the largest star catalog in the world, containing 19 million celestial objects. The catalog was made by scanning over 1,400 photographic plates of the entire sky. The plates are also stored in a giant database, so astronomers can call up a region, like the Andromeda Galaxy, and manipulate the images with false color. In our lifetime, space telescopes should match the discoveries made since the beginning of astronomy.
Well, we hope to see, in the words of Galilei, wondrous things. Those were the words that he used in 1609. We want to see star systems. We want to see images of the planets. But in particular, Space Telescope is designed to look out into deep space, to study deep space astrophysics, to go out to a realm that we've not yet been able to study well.
Louisiana's Delta region is a national resource, providing much of this country's shrimp and other fish products as well as oil and natural gas. But many of the wetlands which serve as spawning grounds for its major fish crops are rapidly disappearing. What makes the situation even more striking is that other parts of this same shoreline are actually growing. It's this dual set of circumstances that has caught the attention of geologists Doug Rickman from NASA's Stennis Space Center and Louisiana State University's Oscar Hugh. Their focus today is a part of the coast where mud is accumulating and forming new land. The mud is sediment from rivers which flow into the Gulf, but why it's washing ashore in certain areas and not in others is not well understood. That's why Hugh also leads expeditions into the Gulf itself. The ocean floor in this area is essentially a broad, featureless plain of sediment deposited by the Atchafalaya River, a major branch of the Mississippi. Using a variety of techniques, Hugh and his colleagues map the muddy bottom to determine the patterns by which sediment moves and land is gained.
To manage this environment, we must understand how it naturally operates. Leveeing has gone on. There are locks and control structures going on. Some of these have been very valuable and others have had very serious negative consequences. And as these environments change, as land is lost or land is gained or land erosion takes place, it has a serious effect on the economy here.
This scanner, called CAMS at the NASA Stennis Center, provides another perspective on the problem. When installed on a Learjet and flown over the study site, CAMS produces imagery which, with Doug Rickman's expertise, clearly shows a growing delta at the mouth of the Atchafalaya. The yellow areas are exposed mud flats. The image on the top is from March 1987. Below it is the same area less than a year later. As Rickman illustrates with this geologic map of the state, sediment-rich waters from the Mississippi being channeled down the Atchafalaya are helping form this new delta. The problem to the east near New Orleans is that old delta regions levied off from the Mississippi to prevent flooding are dying. The goal is to reverse this trend, or at least prevent further damage by better understanding sediment transport.
Once we can understand that, then we can tell people, if you do this kind of action, if you put a levee here, if you dike this, or if you divert the water here, this is the impact you're going to have.
This information could have applications in other coastal areas around the world and provide an important model for dealing with rising sea levels should global warming occur. Studying Louisiana's delta, NASA and LSU teaming up to preserve an important national resource. Every week, a group of retirees gets together at Brookside Golf Course in Los Angeles, California. Bill Graham has been a golfer for years and is used to playing with handicaps. But he now plays with a different kind. A severe loss of central vision caused by age-related macular degeneration. The disease has claimed the center portion of his eyesight where fine details are recognized. The condition affects 1 out of 5 Americans over the age of 75.
Right that way.
At the first tee, a friend helps line up the shot. Bill has to rely upon his peripheral vision. He sees something like this. Everyday activities like crossing a busy intersection are difficult with macular degeneration, and reading a newspaper is nearly impossible. To date, there is no cure for the disease, just measures to keep it in check. But Dr. Terry Lawton of NASA's Jet Propulsion Laboratory in Pasadena, California, is working on an image filtering technique that helps people read.
It's something people aren't used to doing, looking off to the side to be able to read. But that's where their best vision is now. And these filters make it so that they can read 2 to 4 times faster.
This is an example of an unfiltered versus a filtered word. Using a closed-circuit viewer, Dr. Lawton measures the number of correct responses given by Mr. Graham during a test that mixes filtered and unfiltered sentences.
The dogs swam in the water and played all day.
The digitally processed words actually appear less readable for someone with normal sight.
The reality is it is more blurred. What Terry Lawton is doing is not creating a crisp, sharp edge, but with her filters, she's creating enhancement of contrast. And even though you don't need that enhancement, so you see the blurring that she's creating, the person who has certain losses needs the contrast more than they need the sharpness of the edge, and they see better with this.
I want you to tell me in each one of these circles...
Standard eye testing until recently never measured an individual's sensitivity to contrast, which is how well various patterns are seen from light to dark. Dr. Lawton has developed a system that very accurately measures this ability. By hitting buttons, Mr. Graham tells a computer whether he sees the pattern on the screen slant to the right or left. The technology pinpoints his best level of contrast sensitivity, which then gets translated into the way words are shaded or filtered. Eventually, closed-circuit viewers will be on the market that magnify and filter words according to an individual's contrast need.
To hear the birds.
As a result of the research, Dr. Lawton sees potential in using this image processing technique for a future Mars rover vision system. It would assist in negotiating boulder fields, such as this photographed by an early Martian probe called Viking. The filtering acts to highlight individual boulders in the same way it uses contrast to emphasize the shape of letters in a word, thus pinpointing obstacles for the rover to avoid. NASA's Human Factors Research and its ties to image processing, helping man and machine extend the ability to see.
beautiful.
It's a perspective that's thrilled astronauts since the beginning of manned spaceflight. And for over 25 years, crews have looked back in wonder from this unique vantage point, generating a variety of Earth imagery. Produced with motion picture and still cameras, as well as the shuttle's onboard video system, these images provide a visual record of how our planet is changing over time, and along with satellite data, offers scientists in a number of disciplines a significant research tool. Oceanographers can look at currents from the right position with respect to sun angle. Detailed cloud patterns are captured for meteorologists, and geologists can see large areas with very high photographic resolution.
This is almost a vertical shot of San Francisco. As we look down, you can very easily see the fault lines. So from a geological standpoint, this is a very, very good photograph. The sun angle is fairly low, and you can see exactly where the major and minor faults are in the San Francisco area.
Astronauts begin training in Earth observations when they enter the space program, so that by the time they fly, they are thoroughly familiar with the science and photographic techniques involved in the effort. This enables them to make real-time decisions about views from orbit, including capturing phenomena not on the original flight plan.
All those events that cannot be predicted, they just happen. It is nice to have a crew, a set of human eyes to direct cameras and instrumentation to those sites in a very rapid response. And that's the value of the human being.
Earth observations from the shuttle reveal dramatic changes on the face of our planet.
This is a view of Lake Chad in Mauritania, seen over the nose of a Gemini spacecraft back in 1966. Shuttle crews flying over Central Africa in the 1985 timeframe saw Lake Chad looking like this. The only remaining water in the lake is that light gray patch at the upper end of the dark zone. This, of course, is simultaneous with the extensive drought conditions in Central Africa that underlies those very pointed human stories that we read about.
The fragility of our atmosphere has struck all Earth-observing astronauts.
You see how very, very thin a little coating it is compared to the rest of the size of the planet. It's not like the peel on a grapefruit or the peel on an orange. It's not even really like, to me, the shell on an egg for relative sizes. If anything, it's almost as if we're covered by that thin little membrane between the eggshell and the egg itself. That's the tiny little membrane of air and gases that keeps us all healthy.
A major environmental concern today is the large-scale burning and subsequent deforestation going on around the world. A number of shuttle crews have documented this activity.
The intent is to recognize that there really are no sovereign boundaries in our environment, but that everyone, mankind as a whole, is affected by everything that each one of us do.